In this lesson, we use a geometry application to create a dynamic environment to explore a famous theorem. Start a new document and insert a geometry application. In this activity, the focus is on sides and side lengths, so I'll use the Settings menu to switch off the option to automatically label points. Press Menu, select Settings, then scroll up from the bottom and uncheck Automatically Label Points. Then press Enter. It's time to create some shapes. Press Menu, Shapes, and select Regular Polygon. Move the pencil to the centre of the screen and then click. This is the centre of the regular polygon. As you move the mouse, a hexadecagon outline is formed. Click near to the bottom right corner of the screen. This creates the first vertex of our regular polygon. Now move to the left, which is sort of like clockwise for our polygon. The number of sides on the polygon decreases. Stop once the polygon has exactly 4 sides. Then click. Our regular polygon is a square. The next step is to place a segment on one side of the square. Press Menu, Points and Lines, and select Segment. Click on the bottom left vertex, then the bottom right. We are going to create a smaller square inside this larger one. Press Menu, Shapes, and once again select Regular Polygon. Click the pencil tool on the centre of the first square. Then move the pen over the line segment we just created. If the square is highlighted, press Tab, and notice that the line segment now appears as a dotted line. Click to place the vertex on the line segment. Move the mouse towards the left, just as we did before, until it says 4. Then click. Our construction now includes 2 squares and the appearance of 4 triangles. But we need to add them as triangles. We'll use the Shapes tool, select Triangle, and then click on each of the vertices for our triangle. Now go ahead and draw in the remaining 3 triangles. The final part of our construction is to create line segments which we can use to label. Press Menu, select Points and Lines, then Segment. We'll create 3 line segments corresponding to each side of the 4 congruent triangles. Now press Escape to release the Segment tool. To label each of the line segments, move the mouse over a line segment. Notice that the tooltip says Segment. If it says Triangle or Square, press the Tab key to toggle through each of the objects in this region. When the tip says Segment, press Ctrl followed by Menu and select Label. I'll label this first segment A. Now go ahead and label segments B and C. We can colour the triangles to make them stand out. Hover the mouse back over a triangle. You may need to press Tab to select Triangle. Then press Ctrl followed by Menu. Colour, then Fill Colour. Select a colour and press Enter. Now go ahead and fill in the remaining triangles and do them in the same colour. Now colour the centre square, but make that a different colour. Notice that my tooltip says triangle, so I'll need to press Tab. Now that square is displayed, I'll press Control followed by Menu, then Colour and Fill Colour. The next task is to measure the area of the triangles and the squares. Remember, we have two squares, a big one and a small one. Hover the mouse over each shape, then press Control followed by Menu. Select Measure, then Area. I'll place the area of the squares to the right of screen and the triangle areas to the left. Rather than measure all four triangles, I'll create some text. Press Menu, select Actions, and then Text, and just click below the triangle area measurement. Type in 4 times TA for triangle area, then press Enter. Beneath the squares, I'll type the text LS for large square minus SS for small square and press Enter. We can now calculate each of these expressions. Move the mouse over the expression. Notice the tooltip says Text. Press Control followed by Menu and select Calculate. The text prompt is looking for the variable LS, large square. Move the mouse over the measurement and click. Notice the prompt changes to SS. So move the mouse over the area measurement for the small square and click. The resulting calculation is kind of stuck to the mouse. Move the calculated result just beneath the expression and click. Now do the same for the triangle area expression. So our result shouldn't be surprising. If we cut the small square from the larger one, of course we should be left with the area of the 4 triangles. But go ahead and grab one of the vertices on the small square and drag it along the side of the larger square. Notice that all the areas change, so too the calculated results, but the sum of the triangle areas is always equal to the difference between the area of the large and small square. The total area of our 4 triangles would be equal to 2AB. The area of the large square is A plus B all squared, and the area of the smaller square is just C squared, which, with a bit of simplification, leaves us with the familiar formula A squared plus B squared equals C squared. This dynamic representation is so elegant, I think I'll save it. Press Ctrl followed by S. Select the folder and type in the name